Swayam Prabha. Digital India. Educated India.
So India has always been looking at global family. So in space as well, we are looking at how do we build partnership and how do we build a very close collaboration, cooperation, so that we will be able to make use of the space for peaceful applications and also to make the life in this planet a better place to live. So I will just, with my experience in the Defense Research and Development Organization earlier, 40 years, and then now 12 years in IIT University, so I have a unique opportunity of having looked at a government organization for 40 years, and then also now academic environment, which is a great institution, the IIT University, the IIT Universe, with 12 universities in India, 18 campuses abroad, 28 schools with 200,000 students. So I was able to see the academic environment, the vibrance, which I could see in the youngsters. So I'm going to share some thoughts with these two experiences, that how do we shape up our academic ecosystem, which will propel India to be a leader in space. We are already leadership, we have the leadership in many areas, but then how do we make it in many domains? So I looked at the space opportunities, mind-boggling. You know, when you look at the projections in the next 10 years, if you look at the global space economy, 1.8 billion, and then now when you look at the space tourism, which is picking up at 40%, the annual growth rate, that is going to be jumping from about 850 million to about 8 billion. So this is the kind of the speed at which the market is growing. And then all that to be achieved, what do you need is the human resource. In many domains, not only the science and technology, looking at the propulsion, control, guidance, navigation, materials, payload separation, payloads preparation. So besides this, you need a large number of other domains as well. So there's a huge demand. So youngsters who you see here, it's not only for employment, the entrepreneurship, startups. So how do we groom these youngsters to be the best? So that is what is the main topic on which our panel is going to deliberate. And the first thing is mission planning. So when you look at human resource, it's just not only to conceive a futuristic spacecraft or a space mission, that how do you conduct the space mission in terms of planning, execution, then satellite communication, and we need engineers, designers. We need good designers, because the design capability in India is much to be desired yet. So let us build this design capability, which is very, very important. In IIT University, we have already started doing it. And so we need designers. We need system integrating engineers, because there's a big void still in India. The system integration, very few people, handful. So I think we need to develop that capability today in terms of numbers, in terms of critical mass. So let us build that system integration experts. And we also need people who would do aerospace engineering, propulsion, control, guidance, navigation, bringing in the latest technologies in education. When you are developing human resource, we should always build at with the education system, the artificial intelligence, quantum technologies, data science, all this we need to build in the education. And I will share some of the IIT experience, how we are doing it in IIT ecosystem. So when we talk about space education, I would like to divide them into three categories. Just not only the formal education you get in a university or a college or an institution, but you also have a non-formal education, which was slightly mentioned in the previous panel. And non-formal education is also part of the education. Informal education, how do you create horizontal spread of the knowledge? Informal education. So when you talk about space education, it encompasses all these three domains: formal, non-formal, informal. And again, when you come to the subsets, we need science and technology for the spacecraft development, executing the missions. And we need space economy experts. How do you monetize this? whether it's an IPR or it's a business coming out of it, so you need experts in space economy. We need experts in space laws. So it is just not only sufficient to give orientation, but we need lawyers who are going to now argue and then also look at the litigations and legal issues. So we need specialists in the space laws. Then we need communicators. How do you communicate and take the message to the people through informal education? So you need space science communicators. So when I talk about the space education, we are looking at the whole spectrum of the canvas. And we also look at, you have degree programs, diploma, certificate, and also training, and open and domain electives. All this will build the horizontal capacity in our country. So we should look at in a broad-based application of the space science and technology. We should also bring a multidisciplinarity and transdisciplinarity in our education system, which is not happening now. So you have always silos and vertical. So how do you break this? Because a person must know how do you manage a program, so management orientation, legal issues, and also economic issues, costing. So all this need to be communicated to the space experts whom we will be developing. So let us bring the multidisciplinarity dimension when we are formulating a curriculum, syllabus, and also the delivery, pedagogy, the method of delivery. Everything should be very critical to bring the multidisciplinarity. I would suggest the ISPA, AICTE, and ISRO together, that how do we make a task force which will have all the representatives in different domains, and let us look at what are the type of curriculum and syllabus which is required. And we should take the inputs from all stakeholders, from industries, the entrepreneurs, and also the government, and ISRO, Department of Space, all those who are responsible, so that this curriculum we should make the best in the world. So we should also consult the experts sitting over here from different countries, so that there's a global consultation. When we are formulating a curriculum, it's not just for Indian education, but let us make it a global approach. So I would suggest what we make should have the best of every country. How do they teach space education? Let us build that. Then we should also have Industry 5.0. Now that has to be also built in because of the manufacturing sector and so on, and the faculty development. Then how do you groom the faculties to be able to compete and also to become competent to deliver such a multidisciplinary program in space education. So we need teachers training, faculty development, which will provide ultimately the delivery, what we decide as a curriculum. Then learning by doing. We always give more emphasis on theoretical and textbooks, classrooms, but now we need to make it more skill-based and also competency building rather than only the knowledge giving, that they should be able to do it themselves. Similarly, we need infrastructure. If we have to do this, the wind tunnels and also the capability which you require, computational fluid dynamics for designs, so many things we need. So let us build the horizontal infrastructure, research and development infrastructure, which is also much to be desired in our country. So this would be required for even delivering the education. Then we also look at resources. What are the resources required? How do we mobilize these resources? Then emerging technologies. Ultimately, the quality control and quality assurance in terms of the quality of education which we give in space, and for which we should have the accreditation mechanisms, the proper filtering of the quality, and so this would be required if we have to really make the education system very vibrant. Now, I'll just give a little glimpse for another couple of minutes. What Amity do in terms of academics, we run UG, PG, doctoral programs in Amity University, many universities, because it's a universe, Amity universe. So we run programs, and also we have a vertical in very strong research, the base in terms of delivery. Because even our curriculum design is to make them create, innovate, and also ultimately produce. So this is what is the culture which we have created in Amity University. And some of the research which we are doing is like, we have a very, Amity Institute of Space Science and Technology, we are doing a project for ISRO on cognitive health monitoring of the spacecraft using the AI. And similarly, we are looking at the debris management in space. And similarly, we are also looking at the remote sensing data. How do we use it? So we have started so much of research in terms of the space technologies as well as the remote sensing data. Then we have created in Amity, Dubai. We have in Dubai, Mauritius, Singapore, London, US, we have campuses. So in Amity, Dubai, we created an Amity ground station, satellite ground station. So we get a huge database coming from these satellites. And it has got its own advantage of being located in Dubai. So this is a big station which our students use it for data analysis and data analytics and using AI. AI, we have created a center of excellence with 10 petaflop computing capability in the first phase, and it's going to be upgraded to 60 petaflop. Then we are building a CubeSat, which will go this year. ISRO has already cleared those, so it will be integrated, and we are working with InSpace. So the first 3 CubeSat will go this year. It will have a payload which will monitor the atmospheric pollutions. Then we are also sending the first biological payload. Before the Gaganyaan, we put humans into space. From Amity, we are putting the first biological payload of a callus of a vegetable plant, stevia, and also a bacteria into this. And this has also been approved by ISRO, and we are hoping that it will soon go. This year, we have put the target to put it in space. Then we are also doing the other thing which I mentioned, debris management, and we have created a Mars analog station in Ladakh. Ladakh, if you look at the terrain, atmosphere, and also the psychological factors like isolation, monotony, separation from family, fear of the unknown, all this exists there. So we created, Amity created the Amity Mars analog station, and we are working with NASA. We are working with European Space Agency. We are working with Australian Space Agency. So we created this. One experiment we did was extremophilic identification in Mars analog research station. So we have found what kind of microbes survive in those conditions. So we have done that experiments in Ladakh. And then we also have the lunar rover technology, which is again being developed now. Gaganyaan, we have presented to Dr. Somnathji when he visited us in Amity University. Finally, I'll conclude with the Prime Minister's slide, where what he says, India, I quote, India in its 75th year of independence, by opening the space sector, has gifted the industry and the academia an opportunity to tap into this futuristic area. Thank you so much.